Hello, welcome to Astronautics for Exploit. This is Dr. Anyashola Ogundele. Lunar In-Situ Resource Utilization, a path towards financially sustainable space exploration endeavor. The focus points of my presentation are as follows. Lunar Exploration Future Trends, Lunar In-Situ Resource Utilization, Purposes of Lunar In-Situ Resource Utilization, and Lunar In-Situ Resource Utilization Purposes and Methods. Since the dawn of ages, human curiosity about the existence of extraterrestrial life, alien life that originated outside the confine of the Earth's sphere of influence, has led to various research endeavors to search for the existence of extraterrestrial intelligence life, with possibility of having civilizations that might be far more advanced than humanity. Via several scientific missions and robotic explorations, scientific ideas about the possibility of the existence of extraterrestrial life have spurred humans' interest and perspective on exploring Moon and Mars to establish human colony, work, and live in space, and making use of in-situ resource utilization to mine and process Moon and other planetary bodies' in-situ natural resources for the benefit of humankind. Research findings show that successful location and exploration of Moon extraterrestrial resources by the space companies via in-situ resource utilization techniques will help humanity to reduce dependence on Earth-based resources. This will in turn lead to the establishment of financially sustainable space exploration programs by the government space agencies and private space companies. Over the years, investigation and exploration of the Moon as only natural satellite found to have unique space position and abundant natural resources show that Moon is very important for humankind push towards deep space exploration. Human understanding of the Moon, Earth, Moon, and solar systems have been enhanced through various lunar exploration missions. The future trends of lunar exploration are the focus shift from trying to understand Moon to human exploration and uses of Moon natural resources. Short-term exploration endeavor to long-term semi-permanent or permanent human residence on the Moon, and exploration of the lunar South Pole resource-rich areas has been done presently by the India's recently launched rover, Chandrayaan-3. Presently, some of the identified in-situ resource processes for the intended future lunar exploration are oxygen, water, and hydrogen production for life support, fuel, and propellant. Lunar exploration trends. Lunar resources, such as mineral resources, water and ice resources, volatiles, and solar energy, will contribute immensely to the establishment of a lunar base for long-term life support and scientific exploration missions. Based on the potential for the extraction of lunar resources, various future lunar exploration trends are mapped out. Illustration of NASA's lunar flashlight using its 4-laser reflectometer to search for surface water, ice, as it makes a close approach over the Moon's south pole is shown in this picture. The focus of future lunar exploration is gradually shifting from understanding the Moon to making use of the Moon and human missions to the Moon. Lunar South Pole. The future lunar exploration mode is changing from short-term exploration to long-term residence and will gradually focus on resource-rich areas such as the lunar South Pole. An artist's visualization of a 3D printed moon base is shown in this picture. Because of the difficulty, high risk, and high cost of lunar exploration technology, international cooperation are planning to share the costs and risks and the achievements and developments. Thus, it is the general trend of future lunar exploration missions. The future lunar exploration mode is changing from short-term to long-term. Illustration of lunar exploration is shown in this picture. Lunar in-situ resource utilization. Lunar in-situ resource utilization is the mining, treatment, and utilization of lunar natural resources, including lunar minerals, water or ice resources, volatiles, and solar energy. Presently, several lunar in-situ resource utilization processes and technologies, such as in-situ water access, in-situ oxygen production, in-situ construction and manufacture, in-situ energy utilization, and life support and plant cultivation on the moon are being developed. An emerging future moon base is shown in this picture. Purposes of lunar in-situ resource utilization. Major purposes of lunar in-situ resource utilization development for future robotic and manned exploration missions are as follows. In-situ supply of life-supporting matters, including water, oxygen, food, solar electric energy, and a host of others. Construction and manufacturing of key facilities, including manned habitat, landing pads, scientific facilities, transport tools, and maintenance tools. An illustration of a moon base is shown in this picture. Lunar in-situ resource utilization development. In-situ supply of lunar-based rocket propellant, including hydrogen, oxygen, and methane. Marching and facilities supported for lunar-based scientific research, transit, and supply stations in cislunar space for Mars and other deep space missions. Illustration of oxygen depot on the moon is shown in this picture. Lunar in-situ resource proposals and methods. There are various proposals and methods on lunar in-situ resource utilization, and some of them are highlighted as follows. In-situ energy conversion and utilization, lunar life support, in-situ lunar construction, in-situ oxygen preparation, silicon, metal, and fiber refining from lunar cells, and in-situ water replenishment. A lunar in-situ resource utilization approach is a means of energy provision, and it involves the use of lunar regolith as the medium for thermal energy storage. In the in-situ energy utilization on the moon, two different types of systems to produce heat and electricity using lunar regoliths are being proposed. Illustration of based on lunar South Pole is shown in this picture. Lunar heat production system. Thermal weldings made of lunar regolith in order to supply enough heat to keep lunar devices above their minimum operating temperature. A heat engine is activated using solar power and simultaneously heats a thermal mass during daylight. Illustration of mining lunar resources is shown in this picture. Lunar life support is another proposal of lunar ISRU. Long-term manned exploration on the lunar surface requires several survival materials, and that is unrealistic to completely rely on supplies from the Earth. Proposed approach is to in-situ solve key problems such as oxygen and water regeneration, food production, and waste recycling. Building an artificial ecosystem is the most advanced method to achieve in-situ resource utilization and survival materials recycling. Engineering technology and ecological theory are applied to achieve energy flow and material circulation among plant, animal, and microbial units. One of the two lenses for the first lunar outpost is shown in this picture. In-situ lunar construction. The in-situ construction of the lunar base is of great significance for the long-term survival of human beings on the moon. Using local materials from lunar resources to realize in-situ construction is a feasible method that is being proposed. Because of the extreme lunar environment, such as high vacuum and low gravity, the common method for Earth construction are not suitable for the Moon. Proposed lunar construction methods are additive manufacturing, sintering techniques of lunar swells, and extrusion printing techniques of lunar regolith. This picture shows the leaving of the Moon in the ascent stage, which is leaving behind the landing stage. AM techniques of lunar swell. A three-dimensional printing is referred to as the process of joining materials to make objects from 3D models. The technology has been widely studied for building in-situ lunar regolith into 3D objects, which use premised paste composed of lunar swell simulant and liquid binders as the printing material for the construction of lunar 3D objects layer upon layer. Illustration of lunar outpost is shown in this picture. Sintering techniques of lunar swell is another proposal. The sintering process heats the fine grains of metallic or ceramic material to the melting temperature so as to form a fist shape. Solar sintering of regolith via directly obtained and concentrated solar light on the Moon to sinter the lunar regolith would be a viable construction technique as solar energy is limitless and readily available on the lunar surface. The picture here shows inflatable structures made of flexible but tough materials like Kevlar. Oxygen extraction is another lunar in-situ resource utilization proposal. Extraction of oxygen from lunar regolith can provide fuel replenishment on the lunar surface and maintain life support systems, while the remaining metal elements can be applied in manufacturing and construction. Through electrolytic reduction method and vacuum thermal decomposition method, oxygen can be extracted from the world resources. Lunar mobile habitat is shown in this picture. Silicon metal and fiber refining from lunar soil is another proposal. Silicon is one of the most abundant elements in the lunar soils. Most of the silicon elements exist in the form of silicates on the Moon. Nowadays, purified silicon is widely used in solar cells because of its semiconductor properties. On the lunar surface, one of the reported silicon production processes is to heat the lunar regolith in the presence of reductants such as fluorine. A pressurized rover that will act as a mobile habitat is shown in this picture. In-situ water replenishment is another proposal. Water resource replenishment on the lunar surface not only are the most basic requirements for human survival, but also can further realize the in-situ conversion and supply of oxygen and hydrogen through photolysis or electrolysis technology, which can be used as the propellant for rocket launch and the in-situ replenishment of oxygen for human survival. Water resources can also be used as important raw materials for moon-based scientific experiments, lunar surface biological culture, lunar construction, and radiation protection. A lunar reactor, which could also provide power during long lunar nights, is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Lunar In-Situ Resource Utilization, a path towards financially sustainable space exploration endeavor, presented by Dr. Ayanshola Ogundele, with the focus points Lunar Exploration Future Trends, Lunar In-Situ Resource Utilization, Purposes of Lunar In-Situ Resource Utilization, and Lunar In-Situ Resource Utilization Proposals and Methods. Thank you.